Mathematical model of secretion of metatonin, DMT, after enlightenment experiences. Abstract. The secretion of endogenous N-dimethyltryptamine, DMT, also known as the spirit molecule, is a widely discussed phenomenon in the context of altered states of consciousness and spiritual experiences. However, the mechanisms underlying the secretion of DMT, particularly after enlightenment experiences, remain unclear. In this paper, we propose a mathematical model of the secretion of DMT after enlightenment, based on the existing literature and current knowledge of the neurochemical and physiological processes involved. Our model suggests that the secretion of DMT after enlightenment may be a result of the activation of the pineal gland and the release of serotonin, followed by the conversion of serotonin into DMT by the enzyme INT. We discuss the implications of our model for future research on the neurobiology of spiritual experiences and the potential therapeutic applications of DMT. Introduction. N-dimethyltryptamine, DMT, is a psychedelic compound that occurs naturally in many plants and animals, including humans. It is a Schedule I controlled substance in the United States and other countries, but its use as a sacrament in indigenous cultures has been documented for centuries. DMT is also known as the spirit molecule due to its reported ability to induce profound altered states of consciousness and spiritual experiences. Recent research has suggested that the endogenous secretion of DMT may play a role in these experiences, particularly after enlightenment experiences. Enlightenment experiences are characterized by a sense of unity, interconnectedness, and transcendence of ordinary reality. They have been reported by individuals from various spiritual traditions, including Buddhism, Hinduism, and Christian mysticism. While the subjective nature of these experiences makes them difficult to study, recent neuroimaging studies have suggested that they may be associated with changes in brain activity and neurochemistry. The pineal gland, a small endocrine gland located in the brain, has been implicated in the secretion of DMT and other psychedelic compounds. The pineal gland produces and secretes melatonin, a hormone that regulates the sleep-wake cycle, and is also involved in the regulation of circadian rhythms. The pineal gland has also been shown to contain the enzyme indole N-methyltransferase, INT, which is responsible for the synthesis of DMT from serotonin. While the role of the pineal gland in the secretion of DMT is still debated, recent research has suggested that the activation of the pineal gland and the release of serotonin may play a key role in the process. In this paper, we propose a mathematical model of the secretion of DMT after enlightenment experiences, based on the existing literature and current knowledge of the neurochemical and physiological processes involved. Mathematical model. Our mathematical model of the secretion of DMT after enlightenment experiences is based on a simplified representation of the neurochemical and physiological processes involved. The model consists of three main components: the activation of the pineal gland, the release of serotonin, and the synthesis of DMT from serotonin by INT. The activation of the pineal gland is represented by a sigmoidal function. which describes the relationship between the level of activation and the time elapsed since the onset of the enlightenment experience. The function has a steep increase at the beginning of the experience, reflecting the rapid activation of the pineal gland, and a slower decrease over time, reflecting the gradual return to baseline. The release of serotonin is represented by a second sigmoidal function, which describes the relationship between the level of serotonin in the brain and the time elapsed since the onset of the experience. The function has a gradual increase at the beginning of the experience, reflecting the release of serotonin, and a plateau phase, reflecting the sustained levels of serotonin during the experience. The synthesis of DMT from serotonin by IND is represented by a simple linear model, which assumes that the rate of DMT synthesis is proportional to the concentration of serotonin and the activity of IND. This assumption is based on experimental evidence showing that IND is the only known enzyme capable of synthesizing DMT in the brain, and that its activity is regulated by the concentration of serotonin. The complete mathematical model of the secretion of DMT after enlightenment experiences is given by DMT equals K, serotonin, IND underscore activity activation underscore function release underscore function. Where DMT is the concentration of DMT in the brain, serotonin is the concentration of serotonin in the brain. IND underscore activity is the activity of IND, K is a proportionality constant, and the activation and release functions are given by activation underscore function equals 1 plus xba, t underscore 0. Release underscore function equals xb, t underscore 0. 1 plus xb, t underscore 0. Where t is the time elapsed since the onset of the enlightenment experience, t underscore 0 is the onset time, a and b are parameters controlling the shape of the functions, and the values of k, a, and b are determined empirically from experimental data. Discussion. Our mathematical model provides a simplified representation of the neurochemical and physiological processes involved in the secretion of DMT after enlightenment experiences. While the model is based on existing literature and current knowledge, it is important to note that the mechanisms underlying the secretion of DMT are still not fully understood, and the model should be viewed as a hypothesis rather than a definitive explanation. One of the main assumptions of the model is that the activation of the pineal gland and the release of serotonin play a key role in the secretion of DMT. While there is some evidence to support this hypothesis, more research is needed to fully understand the relationship between these factors and the secretion of DMT. Another limitation of the model is that it does not take into account likely that the secretion of DMT after enlightenment experiences varies between individuals, and future research should aim to identify the factors that contribute to this variability. Despite these limitations, our model has several implications for future research on the neurobiology of spiritual experiences and the potential therapeutic applications of DMT. By providing a quantitative framework for understanding the secretion of DMT, the model can guide the design of experiments aimed at testing specific hypotheses about the neurochemical and physiological processes involved. model can also inform the development of new therapeutic interventions. In conclusion, we have proposed a mathematical model of the secretion of DMT after enlightenment experiences. Based on the existing literature and current knowledge of the neurochemical and physiological processes involved. While the model is still a hypothesis, it provides a useful framework for understanding the secretion of DMT and its potential role in spiritual experiences and therapeutic interventions. Further research is needed to test the validity of the model and to explore the implications of the model for the understanding of the neurobiology of spiritual experiences.